Today's lesson is 9.3, Polynomial Functions. Let's go ahead and get started with example 1. They're asking us to find all the y-intercepts and x-intercepts of the graph of the function below. What we're going to do to find the y-intercepts is we're going to go ahead and make x be equal to 0. This question is coming from your Alg assignment, so it does state that if there is more than one answer, we're going to go ahead and separate them with a comma. So for the y-intercepts, we are simply going to say f of 0, and we're going to plug in 0 for the x's in our function. Remember, whenever I multiply by 0, I get 0. So notice that each of our numbers, both of the 2's and the 84, are getting multiplied by 0, and so we end up with 0. And so we have y is equal to 0, which is our y-intercept. If you think of it as an ordered pair, you would think of it as the ordered pair 0, 0. All right, for the x-intercepts, this is where y is equal to 0. So I'm going to set f of x equal to 0, and I have to solve for x. Now notice that each one of my terms of my polynomial has an x. So what I'm going to do is I'm going to go ahead and factor. Now I can only take an x from each one because the first one has 3, the second term has 2, and the last term has 1. So this means they each have an x to give me. And then if I also look at the numbers, the coefficients in front, they are all even, and so I can go ahead and take a 2 as well. So I'm going to divide out a 2x out of each one. So for my first term, 2 divided by 2 is 1, and x to the third power divided by x is x squared, because remember the rule says we just take away, we subtract 3 minus 1. 2 divided by 2 is 1, and x squared divided by x would give me x. 84 divided by 2 gives me 42, and the x is going to go out front. The purple x goes out with the 2. Now I can go ahead and I can factor the polynomial, the quadratic, inside the parentheses. So remember we talked about x squared. X squared is x times x. And then we talked about the 42. Now it is a negative 42, but think of it as just 42 for now. It could be 1 times 42. It could be 2 times 21, 3 times 14, I think. 4 maybe. Let me see. 3 times 14. Let's see if 4 goes in there. No. 5, no. 6. There we go. 6 times 7. Now, I'm going to guess that it's going to be 6 times 7, because I think I can make 6 and 7 become the negative 1 that's here in the center. So we're going to crisscross multiply. X times 6 is 6x, and x times 7 is 7x. I'm pretty sure I can make that be negative x, or negative 1x, if I add together a positive 6 and a negative 7. Yep, positive 6 plus negative 7 is negative 1. So that means I have a plus here and I have a minus here. So now I still have the 2x that I factored out, but then I have x plus 6 and I have x minus 7. Here are my 3 factors. I'm now going to go ahead and use the zero product property, which says one of these 3 factors should equal 0. So 2x equals 0. If I simply divide both sides by 2, x equals 0. There is one of my answers. X plus 6 equals 0. If I subtract 6 from both sides, I get x equals negative 6. There's my second answer. And x minus 7 equals 0. If I add 7 to both sides, I get x equals 7 for my third and final answer. Now what I would do is I would go ahead and put these into Alg 0, comma, -6, comma, 7. They are the ordered pairs 0, 0, -6, 0, and +7, 0. Those are the ordered pairs. All right, the second example for today is asking when is the graph below strictly increasing? Now, what you're going to notice is that you're going to see this word strictly, so it has to only be doing, and then you're going to either see the word increasing or decreasing. Now, one thing that you need to know before we go ahead and start looking at the graph is that graphs are read from the left to the right. Let me go ahead and add that right here. Graphs are read. I know it seems weird to read a graph, but we do read it from the left to the right side, just like you would a book. So you start on the left and you read it to the right side. You start on the left and you read to the right side. So if you notice, our graph starts right here and then it goes down to this point. Notice I said it goes down. That means it is decreasing. Then at this point, it goes ahead and it turns and it goes upward. So this would be increasing. At this point, it changes direction again and goes down, decreasing. At this point, it changes and goes up, increasing. And then notice from this point to the end, it is flat. This is called constant. It's not increasing or decreasing, it's just staying steady. So I'm going to go ahead and read it, and I'm going to say decreasing, increasing, decreasing, increasing, constant. Okay, now you need to know the numbers of your peaks, and it's the x values that you are going to want to talk about. Oh, this one also does ask where is it strictly decreasing. So let me go ahead and put that too. Okay, so here we go. Strictly increasing would be here and here. And then how would I write that? Well, what you're going to have to do on your assignment today is you're going to need to know the x values of these 2 points at the ends, at either end of your increasing interval. So this one would be -3. And if you look at it as an ordered pair, it is -3, -3. And then this ordered pair up here would be 0, 6. This ordered pair here would be 4, -3. And this ordered pair here would be 5, -1. Now it's really the x's that you're going to look at. You are looking at your x coordinates only. And that is true for the decreasing as well. All right. Since the dots are filled in, I would go ahead and in interval notation, I would use the brackets, and you would simply say -3, comma 0 for that first one, the longer one, this one right here. And then you're going to put a comma, and you're going to put another bracket, and you're going to say 4, comma 5 for the second shorter increasing interval. For the decreasing, we're going to put this one, and I'll put that one at a time. I would say, I need this ordered pair, -5, comma, looks like 1. Do I need any other ones? I think that's the last one I need. So I'm going to say -5 to -3. Remember, the smaller number always goes first, and the larger number always goes second. comma, I think there's one more going down, this one right here, this larger one right here, and that one I would put 0, comma 4. Okay. All right. Just a couple things. This is your start. This one would be considered a local minimum because it's a lower value than the start. This one would be this one would be considered a local maximum because it is larger than the start. This one would be considered a local min. And then this would be considered a constant, a straight, a flat area. So it's not a local min or a local max. All right, let's go on to example 3. Here is a graph of a function f. Use the graph to find the following. If there's more than one answer, we're going to separate them with commas. Now, notice that the two questions that are asked, if you go ahead and read them to yourself, they are very, very similar. What you need to be paying attention to is how the question is asked, because one of these is asking for the x coordinate and one of them is asking for the y coordinate. They are talking about a maximum, but they could be talking about a minimum, okay? So if I go and look, here would be my max, and it would be at the ordered pair -1, -1. You could be asked about a minimum. There's a minimum, and that is at the ordered pair -2, -3. This would also be considered a minimum, and it would be at the ordered pair 4, -5. But my question is asking about the local maximum. Okay, so I'm going to do the blue one, is the one that I'm concentrated on. Now notice that this first sentence says all values at which f has a local maximum. All values at which f has a local maximum. This question is asking you for the x coordinate of the maximum or the maximums. It could be more than one, remember. So this would be, wait, did I get this wrong? No. Do I have the ordered pair? Oh, yes, I do have the ordered pair wrong. It's +1, -1. Hold on. There we go. So my answer here would be +1. Now notice that the second question asks all local maximum values of f. Notice it doesn't have that part at which. That's the difference between the two. This one is asking for the y coordinate or coordinates of your maximum. Of course, the word minimum could be used as well. And this one, my answer would be -1. Make sure you pay attention to how the questions are asked when you go to do your assignment today, because they can switch these two and then it gets very confusing. All right, example 4 is going to ask us to use the Alx graphing calculator. Now, instead of using the Alx graphing calculator, I'm going to go ahead and use the Desmos graphing calculator. And it's going to ask us to find the real zeros of a quadratic function. And then it's going to come down here and ask us to find the real zeros of a cubic, okay? I'm going to go ahead and I'm going to use my Desmos calculator, because when you're asked to find the zeros, what they're really asking you to find are the x-intercepts. Where is this graph intersecting the x-axis? That's all we have to figure out. It is asking us to round to the nearest hundredth in both of them. So remember, 100, I'll put it down here, would be the number that I think of in my head. The decimal is right here. tens, hundredths, and the number right after is going to tell me should I let it rest or should I add one more? All right, let's go ahead and take a look at Desmos. Oh, I don't have it. That's okay, it's right here. All right, here's the first one, the quadratic, x squared minus 6x minus 1, it said. All I have to do is click on the two x-intercepts right there, and notice that Desmos does have the two, they already have them rounded for me, but they rounded to the nearest thousandth because they have 3 numbers after the decimal. I only need 2. So I do still have to round. Um, for the first one, negative 0.158, the 8 is going to make the 5 become a 6. And for the second one, 3.158, once again, the 8 is going to make the 5 become a 6. So my answer is going to be, let me go back to my good notes, negative 0.16, comma, 3.16. Oops, sorry. 6. There we go. Because these were the ordered pairs. That I had from Desmos. So decimal 1, 2. This one's going to tell me to round up. Decimal 1, 2. This one's going to tell me to round up. All right, now I can pull up my Desmos for the B one. Here we go. Yay. Let me get rid of that one and let's put it in. 2x to the third. Get out of the decimal, or get out of the exponent, plus 3. It's the x-intercepts that I want, so there they are. And then I can go ahead and I can write them all down. There's 1. Here's the second one, and I'm not putting them in any particular order. I'm just kind of putting them in the order that I see them. And it looks like negative 1.658, comma 0. There we go. All right, let's go ahead and slide that off to the side. We're going to count 1, 2. This one's going to say leave it, so my first answer is going to be 0.40. Now, do you need the 0 after the 4? No, but since Alex did say to the nearest hundredth, I'm going to put it because that is the hundredths place, and I just don't want Alex to count it wrong. It shouldn't, but you never know. Here, the 6 with the arrow is going to tell me to make the 5 a 6, so I'm going to put 2.26. And for the last one, decimal 1, 2, once again, the 8 is going to go ahead and say make the 5 a 6, so 0.66. Here would be my 3 answers because I had a cubic. All right, our last example today goes with our last problem, and this one is probably the trickiest. Below is a graph of a polynomial function f with real coefficients. Use the graph to answer the following questions about f. All local extrema of f are shown in the graph. Remember from the beginning that we talked about graphs are read, or that we read them from left to right, just like we would a book, just like I did that sentence. Okay, so I always read from left to right, even when I'm reading a graph. So here is my left, here is my right. I'm going to go ahead and read it for increasing and decreasing because they're going to ask that question. They're going to ask questions about what the leading coefficient is. So we're going to have to go back to 9.2 where we talked about the end behavior and all that kind of stuff. So let's start with my graph is decreasing. at the beginning because it starts up here in the left corner and it's going to come down to this point, which happens to be a minimum. And this minimum is at the ordered pair -8, comma 1, it looks like. Then it looks like my graph is going to turn and it's going to increase to this point right here, which happens to be a local maximum, which is at the ordered pair -6, comma 3. Then my graph is going to turn and it's going to decrease to this point right here, which is a minimum and is at the ordered pair -2, -2. Then my graph will increase to this point right here, which is a local maximum, and it is at the ordered pair 3, comma, maybe 5.5. I'm going to guess 5.5. The y value isn't going to matter. It's really the x value that I need, so that's okay. Then it's going to turn and it's going to decrease to this point right here, which happens to be a minimum. And it does appear to be at the point 7, comma 0. It takes one more turn upward to this, which is a point, which is a maximum. This appears to be at the ordered pair 9, comma 2. And then it decreases until infinity, or till infinity. Okay, this is infinity over here. Oop. That's not the symbol for infinity. This is the symbol. This one is negative infinity. All right, so the first question is going to ask you about increasing or decreasing. It just depends, so please make sure that you do read. This one says the function is decreasing over which intervals. So we're going to go ahead and pick them. Notice that our graph was decreasing right here. It starts at negative infinity and it ends at -8. So I'm going to go ahead and click this box right here. All right, then it started increasing, then it decreased here from -6 to -2. -6 to -2. So I'm going to click this one as well. I'm going to continue reading my graph. Notice if you mark it, it's much easier to answer this question. There we go, 3 to 7, 3 to 7. And let's see, there's one more right here from the last max to the end, which is 9 to positive infinity. The ones that are left blank that I did not click, if you take a look at them from -8 to -2, my graph is increasing from -8. Oh no, -8 to -2, it goes from here to here. It doesn't work. And 7 to 9, that one is an increase. 7 to 9 is an increase. I don't know why they have that one. That's weird. Okay. The next question is going to say the function f has local minima at which x values. So they're going to either say minima or maxima, and you're just going to go and you're going to find all your minimums. Now, I did the minimums in purple and I did the maximums in blue. You just need the x values. You just need the x values. Notice it just says x values. If there's more than one, we're going to put them with a comma. So it's -8 at the very beginning, then it's -2, and then it's 7. If I were to do the maxima, I would put -6, +3, +9. All right. Question C is going to ask, what is the sign of the leading coefficient? Remember, for the leading coefficient, we're going to look at the right side, because the right side tells me my leading coefficient. Now, here is the right side, and so I'm looking for this part right here. Notice that it's falling. Remember that the rules say if it's positive, it rises, which means it's going to do this. And if it's negative, the leading coefficient, it is going to fall, which means it's going to do that. Look at our graph. Our graph on the right side appears to be falling like this. So I'm going to go ahead and say that it is negative, the leading coefficient. All right. For the last question, they're going to ask you about the possibility of the possibility of the degree of f, and you do get a choice as to all of them that apply. The first thing that you need to do is you need to count. Here we go. I can make that look better. You need to count all the extrema. That is your minimums and your maximums. You have to count how many total you have. Okay, so we're gonna go back up to the top and we're gonna go ahead and we're gonna count them. I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I have 6. We are always going to add 1 to that. You always must add 1 to that. And so my answer is 7. Okay? My answer is 7. Now go ahead, you're going to look there we go, at the left side of your graph. And you want to look at the left side because you want to compare it to the right side. Is it doing the same? Is it doing different? If it is doing the same, then, let me change this one. Then you have an even degree. So you would pick 4, 6, or 8. If it is doing, so if it's the same as the right, it's even, or it's going to do the opposite of the right, which means it is odd, which means you're going to pick 5, 7, or 9. Now remember, it has to be 7, and so then it has to be 7 or more. It can't be any less than 7 because there are 6 extrema in total. So I've already ruled out 4, 5, and 6 as an answer. I just want to see, am I right that it's 7 or should it be 8 because it's even? So I'm going to go up here and I'm going to look. My left side is rising. My right side is falling. So they are doing opposite things. So it is odd. So the 7 was correct. And so since it is this one, let me grab this. It is this one because they are doing opposite. My degree is going to be greater than 7. It has to be 7 or greater. So I'm going to choose 7 and I'm going to choose 9, but I cannot choose 8 because it's not an even. I can't simply choose everything because it is an odd function with the up and down.